So we came to the conclusion that we haven't done the full tour of the ViewModelEditor. So there's a few items left that we should probably address. So we're gonna jump straight into that. Let's see where we were. I think I should have a browser here. Oh, it's over here. So as we're chewing down this long list, we last time was able to only talk about 3 things. Or we talked about a lot of things, but the 3 things that we can check off. And now we come into seekers and server-side jobs and clone and what we call the JSON functionality we call Tyson. So let's get started on that. So what about seekers? Well, every application or every user of an application needs the ability to seek to find a specific route if you want to have as a handle or a route to a particular view, to look up more information for a specific use case. And since this is a quite generic thing that you need to search, we have a generic way to handle searches, and what we call it is seekers. So that's one of the 2 major, or rather 3 major parts of the view setup that is available in MDriven. It's the document form, which is a rooted form that shows information based on a route, and then there's the browser, more like, that isn't rooted in anything but possibly shows all instances of something like a like this one, just showing all instances of things. And of course that's fine if you have like 100 or 1,000, but if you have 100,000, that would be impossible. So then you need a seeker to reduce the set that's shown on the screen so that the user can find it. And there's a pattern for that in the UI first. If we say that we're gonna search on things, we can go on UI first and say that we want to auto form of the type seeker, and it helps us and fills in based on the type that we have chosen. This doesn't need to be rooted because it doesn't require an initial object. We're not using anything from self in the initial columns. So how this works is pretty, I guess, needs some explanation. What we see immediately is that we get these orange things, which we call search expressions.
Hans,
yes.
Can I just, 2 things. Henrik says that he can't join, that there's some, he said, it says something.
Okay, admit.
I don't know.
No.
Oh, now he is in there.
So,
and then I wanted to mention about the seekers, the background to this whole, why we have chosen this way to do a seeker. And of course you can, take pieces out of this and implement if you want it another way. But the basic idea is that everyone wants Google, but that usually doesn't work in an application that is like domain specific or an administrative style thing. You don't want it to be just like, yeah, we think this is the right stuff. If you input an invoice number, you really wanted to find it, not another one that looked like I wanted instead. So this is a way to try to combine these two, the precision of exact searching with the feel of you just input whatever you know and you press search and you let the machine do the job instead of you. So that's what this is about. And then you could root this in something specific in your model, but Hans is taking the most generic example.
Yeah.
Sorry, Hans, go on.
Yeah, good. So maybe we should add a few more easy searchable strings to show how it would behave. So if we have 2 or 3 searchable strings here, and this UI first will pick all the strings to help you search for those. You can of course search for anything, doesn't need to be strings, but strings are easily searchable and often used in search. So if I now press copy seeker out to form again, it will redo this process. Now it found that I had a couple of more strings, and what happened was that it added more search expressions. So why do we have multiple search expressions? That was the thing that Lars alluded to, that we want a Google-like behavior, but we also want the precision of structured information. So how can we get that? And this is actually based on user experience and how users behave, is that we only want one search box initially and one search button. Of course, we could work with a lot of different search boxes. You should fill box number 2 if you want to search for attribute 2, box number 3 if you want to search for attribute 3, etc. But that's perfect for engineers and technicians, but not for the common user. They're just going to enter a phone number and they're going to hit search. And if one of these attributes is the phone number, let's say it's the this sum string, that's the phone number. What the logic will do when you hit search, it's gonna use this first search expression group and execute this in persistence storage, which means that if you're connected to a SQL database, it will turn this into SQL to execute it efficiently in the database, and it will get back a few thing objects that match the criteria. So let's say this was the first name of a person. That there's no one that will match the phone number that the user entered here. So the result from this is actually 0. There would be no hits. Of course, that could be fine. We can just show a blank screen to the user. But what we know is that the user will not be very happy because he's looking for a phone number and we didn't find a match on first name. So that's we haven't really helped the user at all thus far. So what the logic is going to do is going to step to the next available search expression. And it's going to execute this search in the database efficiently with SQL. And also find that there is no one matching the street that has a street as a phone number. And as we're going to continue then automatically, so the user won't notice that we do this, we just loop through this, and all of a sudden we find a match on someone's or a couple of phone numbers that match the numbers that we have. And then we get a result like 5 entries back. And then we stop. The logic stops, and the result from this search logic is it that will update the generated variable called vSeeker_result with the result returned from this. And then it will stop. So that's one way to sort of Googlify the search without having lost to free text search. We still have the precision, but we can guess what kind of result the user wants by testing many ways. And if there was no one matching this result, then we will, in this case, fall back to run this query in SQL. So this will return all the instances. But hopefully this is limited, and we can see that we probably have a tag value on, at least we can have a tag value on the search expression to enable a limitation that we don't want all. But normally the default is that a seeker only shows, I think it's 200 for VPF, and I think it's less. I think it's 100 for the web. But we can control this by adding this max fetch on the search button. So max fetch, I'm gonna add that and say that we're gonna we'll be fine with 10 for this example. So whatever happens, even if we don't find anything, we will end up here, and then we will only show the 10 top on from the database.
So Hans, I had to solve this same problem in the old ECO. I won't go through all the specifics of what I did, but another feature that was important besides searching multiple attributes was a progressive search, so that as you typed a phone number, you know, your result count went from 50 to 20 to 5 to 1. Yeah. And I would have a little label on the screen that showed that number of results, but also a partial search, right? So like in our case, we'll search by a vehicle license plate number. And all I've got to do is type the first 3 or 4 digits, and usually I've found it. I don't have to type in everything. But that progressive search was pretty important to the way we did it.
So if we want to do that, we would need to resort to a periodic action that's it could have like any interval, but what we want to check is only to enable it when there is something new in the seeker parameter that we catch here. So whenever we have updated, we're going to remember what it was we searched on before, and then we will have the read-only expression to become true if it's after we have searched, so that we don't loop without need. And once we have a new value to search on, we can use the self VM and call search. Yeah, if should be able to call it.
You're in OCL now. I think you're editing the wrong column.
Yeah, probably. That's one. Good. So we can start the search programmatically as we find a change.
Yeah, we did pretty much exactly the same thing, except we had to use a timer on WinForms that looped every half second. And if our user input changed, then we would run our query.
Yeah, so that's pretty much what the periodic actions do. the good thing is these work wherever. It's WinForms VPF or in the web as well. And also the timer sort of stops completely when the expression is disabled. So it's very much as we saw last time, a derived attribute that can react, or a derived action that can execute whenever something changes.
And another powerful part is this could be used, you could search the same classes in multiple UI areas. You don't have to reinvent this searching system because it's attached to the actual class.
Yeah, so it's easy to add a navigation to get to this view, and then you have new actions to jump to different views from here once you have the result. So this is a really powerful thing to help you to reduce all the troubles that comes from enabling a good search on detailed structured information.
Is it possible to limit the search results without using the tag value, using like top 10 or something like that?
Well, the tag value will instruct the SQL server to only return the exact set. So that's
on
more
the other level.
Yeah. Of course, you can do anything with the search result once you have it. You don't necessarily need to show it in a grid. You can, as Damien was alluding to, you could have like a label showing just the size of the result set, that now you have 15.
Yeah. So if you have like 100,000 of order items,
Yeah.
and you're searching for first name, and you type A,
Yeah.
you don't want to...
No, so then you probably want to have a pretty short, if the aim is that you're going to find one, there's no need to return 100. So probably you have the max fetch to like 10 or something, so that to instruct the user that you're still not there, but you're
keep typing.
Keep typing, yeah.
So can you run the seekers in parallel, or does it have to do them in that kind of cascading waterfall model?
It does it in a waterfall model, and what we have found that is actually not a big issue, because it's not waiting around between the searches. It's just throwing away one search, and that returns pretty quick if we have index on things, and the next one and the next one. So it's nothing that the user actually reacts to, that we loop through these. But then we have a cursor stuck on the one where we found something. So possibly one of the users had an address that was almost like a phone number. So we got stuck on that, and now we show like a person's address instead. So what?
Right, that would happen to us with, say, a vehicle VIN number versus a license plate versus a mailing address.
Yeah. So what we have found in our animal studies is that the user will hit search again. So that's a good thing, because we could keep a cursor that we found something here and show that to the user, but the user hits search again without changing anything in the seek box, in the seek param. If the user hasn't changed anything, just hit search again, then we take that as a indication that the user didn't like the results. So we continue. So this gives the very good effect if you're searching among a lot of numbers, like you have an article number, a phone number, a shoe size, and a street number, and you just enter something. Then you can just hit search, 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 search. Now I found what I needed. And then you're done. And that's very close. Once the user has discovered that this is how it works, it's fast and intuitive to address the different needs to find stuff we have found.
Could you search a derived attribute with this?
No, you can't search derived attributes, so that's an issue. And the reason for not being able to search them is that they are not persisted in the database. What it tries to do is to expand derivation. So you could write a derived attribute here and it will expand it before trying to turn it into sequence. So simple derivations may work, but you quite often resort to needing sort of a persisted derived attribute.
So that's the exact problem that I bumped into.
Yeah.
And I would never do anything that's engineeringly questionable. But here's what I did. For all of the attributes that I want searched, I build I build a persisted attribute that I populate regularly with all of the data I want to search, but with special characters stripped out. So, and I call it super search. And so that big text field will have the phone number, the mailing address, the email, with all of the dashes and spaces and @ signs and that kind of stuff stripped out. And that's what I search.
Yeah.
It works well, but that derived attribute, that persisted attribute that I'm searching against can get out of date.
Yeah. So, and that's a truly common problem that goes under the name cache invalidation. So everyone has this, and I think it was said there are only two really hard problems in computer science. One is cache invalidation, and the other one is naming things. So cache invalidation, we have a problem we have solved with the functionality in MDriven server. So what cache invalidation is really the ability to know what stuff depends on. If you know what your derivation depends on, and you can watch, just like we do in memory with subscribers, to know when anything that it depends on, the derived attribute depends on, changes, then we invalidate the derived attribute, and then we recalculate it the next time you want to look at it. So we can do that in the MDriven server database with what we call cache invalidation. It's quite simple.
Well, the other reality is most of the time your user's going to search new data, not old data, right? You're dealing with a new customer, so you want to find his phone number, but he's brand new.
Yeah. So what cache invalidation does is it reacts continuously on changes. So it will be a lag, depending on how much queue you get, but a few seconds before the persisted derived attributes are up to date. And you can use the cache invalidation for like anything, and we use it for complex things as well as reports, because there's quite common need that that you have a structured document with a lot of data in it, and you don't want to regenerate that every night because you might have a million of them. You just want to regenerate it whenever something has changed. And also some users might ask for a specific date when it was updated, when something changed this document. And that's really, really hard. And if you're going to loop them over and just redo them, how are you going to know if they were changed against the old one, etc.? Cache invalidation solves all that by just reacting to really complex. You can subscribe to anything in the model just by describing the stuff that you need watched in a in a view model, and then you're done. So it sort of kills something that you usually need to struggle weeks with getting right. And also with this cache invalidation, you always are in an uphill battle because things change in your model and definitions changed, and you add something more that should be part of this derivation, and it's really, really hard to keep up to date. So that's
the other powerful thing about this seeker is you can pick which attributes, right? That was a problem we had. You don't want to be searching prices or, in our case, a part number or an invoice number when you're looking for a phone number. So, but with this, I'm assuming you just pick which attributes your seeker looks at and remove others, right? Exactly. So this is just the template that has given me stuff, but these are just OCLPS expressions, and you can have as many batches as you want, and you can also have multiple criterias within one batch. And how this works is that these will be intersected. So the results from this will be intersected with the result from another one. So you can have like 5 different rows here with different criterias, and they will all be intersected with each other. And the neat thing is that the active expression will say that if it should be active in just this search. So what you're going to use that for? Well, probably once your search, if your simple search with just one box and search doesn't cut it for you, you put some checkboxes here that says, but only the ones in production, or only the ones in manufacturing, or only the ones that has yada yada. So checking those checkboxes, you can turn on expressions that will be intersected with your first expression. So that will make it real easy to have just a checkbox that cuts away 95% of the results. So those will not come in question at all, etc. So it's extremely simple to do it, the initial setup, but there's really no limitation on how complex you can get this. But as we did this, we found that one of the issues that we had with multiple criterias like this in one group and a lot of intersections is that you can't really have order by. Because order by, what's an order by within an intersection? That won't work. Order by is on the end result, not on the part result. So we had that for a few years, scratching our heads how that should be handled. And just recently we have introduced a thing we call order expressions. Let's see. So this is rather new, but you can have one of these and name it order expressions, order expression, and the UI doesn't update straight away, but in this you can have you can put your order by,
and if there's want to order on many, you would do it like this on many different things. And this also adheres to the active expression. So that means that you can decide on what the whole should be ordered on by having multiple order by expressions. And we have recently added more stuff to make this work on the web as well as VPF.
Yes. Can I add in a little bit there?
Yes, please.
I'm working on improving this whole sortability in seekers and tables in general. And there are like 3 different ways that you want to do things, right? You either want to search the whole, in the database because it's too much to load into the web server memory, or you load chunks into memory and then you search, you sort that, or you sort on the client. So we will implement a way to make the headers. We are testing it now, so it's almost there, that you can click on the headers, and that will update a variable in your view model. And that variable is what you then include in that criteria to turn on and off the different sorting orders. And you also have this visual feedback. So that's the way we've done it. But the gut reaction to that is like, why do you complicate things? Because it's so simple. Every UI you can just click on the header and you're done. Well, yeah, and that's what you can also do in all tables now. You can turn on client sortable. It's called the tag value. That will be visible and documented soon, but we haven't. It's not stable yet. And then all the headers will be client sortable. That is that they are sorted on the client in AngularJS. The problem, of course, is that let's say that you have now a paged search where you have the top 50 showing, and you have found it on telephone number, but you have 150 total that you found, and then you click to search those on last name. Of course, your intention then is to sort all 150 on last name, not just the ones that are showing on screen now. So client sorting is no good in a full-blown seeker. Client sorting is great if you have all on screen, but it's really useless and deceitful to the end user if you try to do that. And then the middle ground here, of course, is that you have loaded maybe 150 on the server, but you don't want to send 150, or let's say you have loaded 3,000 on the server, but you only have 200 on screen. Then it would work if you want to do that sorting like on your own, not in the seeker on the server side, but only show a subset in the client. So you need to have these 3 like different options in mind. But we will implement the first, this seeker one, and we'll have implemented the client one. The client one is super simple, and I think it will be default on all tables soon. But the server one, you have to do some implementation in your seekers, like Hans showed, because otherwise there's so many variables going on. There's so many things that needs to work together, so it's not possible to auto-generate it for every use case. So you need to tweak that. One thing that is also coming now shortly is that is available in VPF, but it's not available on the web, is that it will highlight the column where the seeker stopped. So let's say if it's looking for address and then it comes to the telephone number, it will highlight that column in the user interface. If you have told it, if you stop on this red one, please highlight this column, and then it will highlight that column. So I would say 1 or 2 weeks, and we will have this all sorted out. And it's been a long wait, but we've really struggled to find a generic way to define this, to give a good flexibility from the design point of view, and then spanning these different scenarios, because otherwise it just doesn't work. So that was my addition.
Yeah, so as the client side sorting, that's how we're used to see in VPF and WinForms, but it hasn't been available in the web grids until now. Yeah.
One more thing, when I think it was Bengt who asked, when it comes to, if you want to cut down the amount of rows, I've more and more found it quite useful to add filter logic, what I call it. So let's say searching in the SQL server is search, and filtering in memory is filtering. So there's nothing preventing you from doing things like take a vSeeker result and then do subsequence 1 to 50. That's one way, right? And then you could easily have a drop down with how many results you want to see, and then you cut it on the server and don't need to send it to the client. Another way is also sorting there, but there are also other ways of doing it, like you don't need to actually show seeker result right away. What you can do is in your search function, you search and you get your seeker result, and then you use a for all for each, and then you like copy and do things before you show it to the user. So you can search for one thing and actually, create objects. I have one, for example, when I do 2 searches, and then I put it all in one combined list of another class, and then that shows to the user. So that's one take on it.
Yeah.
And also remember that the OCL expression doesn't need to start in the class that it ends up in. So you can search in a completely different class, like the name of the customer if you have a customer table, and then look the invoices up from that.
Yeah, and it's quite often that even if I started with saying that we have 3 types of UIs, that we don't end up in a clear-cut one of 3 types, that you mix a lot, that you have sort of rooted document forms with an embedded searcher for something else in it, because that was what was needed for this use case.
If I don't want any input from the user, just do the search, are there any drawbacks using I don't really remember the name of the function on ViewModel, I think, for running a PS query?
Yeah, so there's it will be equivalent. If you just want to spin off a PS fetch in the database, you can do that by execute PS query, and then you say what type that you want to end up in, and you say let's see, this is
the one is for the nested.
Yeah, the nesting name and the column in the nesting. Yeah. So
you can also have a column called _PS, PS expression.
Yeah, and
it will have the same functionality.
Yes, that will be evaluated immediately.
So when you don't want any button at all, you just want to show the result, but you want to keep it because there are new data created. I use refresh on the view model on the periodic action.
So okay, if you want to fetch it from the that other users has done changes to your common database and you want to see that.
Yeah. Or server side or incoming data from another system.
So currently that will be most often found automatically by the new Signal R functionality. So UIs will update when new data that adheres that are added to the links. Of course, if it's a search, it won't find it because it doesn't has any subscriptions to the area that you want to do. So you have to execute the search again. But otherwise, things will get updated as you just watch. You don't have to refresh.
Or use the refresh.
Yeah, or use the refresh if you can't wait.
Yeah.
Good. So if we were to try this, I think I'm gonna fix these because I've added the order by expression down there. So I'm gonna remove these and I don't have any good example for this, so I'm gonna remove that as well. And there's an action for getting here, so if I do like play, okay, I'm gonna run XML and okay, and then I left my button with without any criteria, with a search and being a periodic action. So that's what it's doing now. Not too smart. And now it's highlighting that one. So if we were to add some for this one, have this, okay, we don't have those values here. Gonna add attribute 1 and attribute 2 over here. And let's say that this one was like this and this one was like that. So if I were to search AA search, it returned attribute 1, but that was not what I was looking for, and I search again, and now it's returning attribute 2, and now it returns the sum string. So this would have been even more clear if I had put it on 3 different objects. And if I search for 1, I find this one, and I only find that one. So this highlighting, that comes from a tagged value on this box that it's gonna highlight the column called thing the ViewModel class thing attribute 1. So it's going to try to highlight that one. So depending on which box is used, the right column will be highlighted.
And that will soon work on the web.
Good. That's the seeker. Very important entry points. And as you, if you read like Eric Evans' book on domain-driven design, etc., on how to build object-oriented systems with domain layers, they always start with the repository, which is one sort of root class with links to stuff that isn't too many. So you gotta navigate your way through to a repository, because there's with the searcher, you can't get around the searcher. You must have a searcher. Right. Server side. So a bit with the server side, it's part of the MDriven server. So the ability to run things not on the client, and that's an important function that you need to have when you want to assign numbers or do things async. You need to spin work off to someone else that does it for you. And why should that be complicated? Well, it shouldn't. It should be super simple. And we have the server-side actions, but we also have the sys async ticket thing that is a pattern that's covered by the MDriven server. But I guess we're going to talk about, it's better to keep it clean, to just go over the server-side actions as they look today, because they are still effective and important.
Can I just make a clarification there that tricks me up sometimes? I mean, in this case, server-side means on the MDriven server, but instead of the turnkey server. But it's actually the turnkey server that does everything, right? So client side in this case is actually inside the turnkey server and not the JavaScript web browser, right? So, but it still makes the same sense, because if the UI, like the rendering thread of the turnkey server gets stuck on doing a lot of hard lifting, long time lifting, it will affect the user look and feel. So you want to send off an async ticket, or you want to have server-side things that does things like not inside the UI work.
Yeah.
So server-side means here not the UI.
Exactly. And also it's a common place, so that if you want to synchronize things between users, that's a good place to do it. So there's one that knows where everyone else are. So what I did now was just to start a distributed system with an MDriven server and a turnkey server. And if I press play on that, I'm going to point it to that local server, MDriven server, and start that. And if I run the model there, there will probably be no objects, because I recreated that database. So A, B, C, and D, save. And A is found and B is found, etc. Okay. So what's a server-side work? Let's look at the MDriven server interface. So that's a web application. That you're gonna So this is just the local core version of it. So it has, if you don't know, it has A as user and 1, 2, 3, 4, 5, 6 as a password. It's no problem because it's local on your machine. So there's this place on the server called periodic actions. So that's what we call server-side jobs. And it's just as easy as this. You might want to run something asynchronously on the server. Let's do let's take one of the thing objects and have an action that takes the thing object and takes attribute 1 and adds an X. So that's a job that someone could do. When should we do it? So then there's this option, edit criteria for server-side execute. When should we do this? And then we need to state that we want to make this available for server-side execute. The MDriven server is going to check this every 20 seconds if we have set it like that, and it's going to check for as many as there are. And the criteria to actually find the ones to work on, well, in our case it can be thing all instances, but we might not yeah, let's do it on all. So having done that and saving this model and sending this model up to the MDriven server and refreshing this. Yeah, actually we need to push this one, update server-side jobs. We now have a new one called ViewModel1. So that's one job that's gonna run every 20 seconds. So that would mean that we should be able to see that happen on all the things that we create. So it has added 1x there. And let's see if I open a new, if I change this to this view all things, gonna add the attribute 1 and attribute 2 over here. So this way I can have it doing things without the user being involved. And of course, using state machines and different scenarios, I can make it select only the one objects that I want to assign X to and have a criteria. So let's say that I have a real simple criteria that I have this some integer and it's only the ones with sum int equals 1 that's gonna be picked. And okay, let's increase the speed on this, like every other second. And uploading the new model and the server-side jobs to the server, and just verifying that that has been done. I should be able to refresh this, and let's see if let's see. So this one gets updated. It doesn't, because it's only the ones with a 1 over here. So now it's updated. Like that. And actually, yeah, I guess we can see it updating it. Yeah, so it will be updated when the server discovers that there's work done on it. It's not on every go, but and as soon as I put this one at something else and save that so the server sees it, this will stop. And we use this all the time to do server-side jobs that we want to move away from the user. It can be a slow job, or a can be a job that needs to do something special, like sending an email, and the client won't be able to send the email. Probably could be sending the email by using REST APIs and things like that, but the built-in email server or email relay in the MDriven server can do that for you, or generate reports, etc.
Number assignments, if you have an invoice number sequence and you want that to be assigned in one place only, this is a place to do it.
Yeah. So
and because it subscribes, and you can even turn on that it's a real-time attribute. The user will have a quick feedback that the number has been assigned. So usually it's a matter of a second or two maybe that until you have that. But then we usually don't nowadays use server-side jobs. We use a special kind of server-side job called async ticket. So you send a ticket to the server, which is actually a server-side job that is running, and the number gets assigned, and then the user sees it.
Yeah. So and there's quite a few specific actions that can be done that's documented on the wiki. Like you can write a file, etc., to export things, and we also have the ability to read from a SQL database to import stuff from other databases. So we always put our system connections to, or what do you call them, the dependencies to other systems here, and also write in other systems databases by doing insert and updates directly to the SQL servers from here. So it's a very, very useful way to stay in the model-driven world, but still have full interoperability with everything else. Of course, you can use the REST APIs interface operators to call other services to fetch data as well.
And also think about using state machines to control what is going on. So if you want things to happen server side, use state machines to define what you want to happen. And then some of the steps in your state machines gets executed in the user interface when the user acts on it. And then the next step could easily be taken by a server-side job. So you have an enable expression that tells the system that this is something that the server should act on. So it will find the state machines that are in the desired state to act on. And then there's either you step it yourself, you could say, and get the effect. So I usually put the code in the effect part of the state transition, or in the state, the entry to the new state. Or you can use, I mean, you don't necessarily need to trigger the state machine specifically. You can use a trigger state machine general OCL command, and that will trigger the state machine to whatever it can do. So then you can have like a state machine that runs its course based on server-side jobs. So you can fetch data, process it, do things, and then stops maybe because the next step is user interaction. And when the user has cleared the hurdle for some reason, the state machine resumes running on the server. It's a very, very efficient and very debuggable way of passing control between a user and a server. Much better than trying to reinvent, all these state things on your own. Usually always fails.
And it really invites to a good way to divide your problem into many different small buckets that are persisted between steps. So if there's a power outage, that's not a problem. The user can pick up where the stuff was left. And also it scales really well if there's hundreds and thousands of users doing things in their own time. They don't have to do everything at once. They can leave and fetch a cup of coffee, and there's no locks in the database or things like that is easily done if you try to do an imperative program to fetch all the stuff needed to get the job done. So it really, once you start to assume that everything is available to everyone whenever, and there's no real cost in persisting things, then a lot of hard problems get simple. So watching the time that we have consumed it. So I guess we need to draw a line and pick up in 2 weeks.
Yeah, there are more things to tell. I can talk a little bit more on state machines. And server-side view models also. One thing that we might mention in this section, because we're talking about view models now, is that a good way, it's also good to define the data that your actions are executing on if you're concerned about performance, because before the actions are executed on the server-side view model, all the data that is pointed to or defined within the view model is efficiently fetched, and then the actions are executed. So there is a performance benefit to defining what we're actually going to work on.
Yeah. So thank you everyone, and hope to see you soon again.
Yeah. Bye.
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 Bye. Thank you.
Bye.
Thank you. Bye.
Bye.